Hello friends. Today we're continuing where we left off. Done with variables. We'll move to operators. I might slow down on some of them. Depending on the topic, since I may need to cover different subjects at different levels in the future, I won't be going into detail on some of them right away. Some of them, so please keep following the series. At certain points, we'll continue by repeating some parts on purpose. If you follow this training series properly and do the examples, there's no way you won't learn. It would only be because you were lazy. I guarantee that. So, what are we going to do now? I'm going to open a new module. You can open something new directly from the top. It's better if you go to File, New, Project. I'm doing this so all code is in a single GitHub repo. I'm working with modules. You don't have to. By the way, let's open a new module. When I click Create, yes, my new module is here, guys. Now, right here, I'm adding com.muhammed.runnerzip here. This part is about operators. First of all, there are the basic operators you already know from math. These are arithmetic operators. Then, there are assignment operators, which make arithmetic operators meaningful. In other words, when you get a result, you need to assign it somewhere, and that's what these operators do. Guys, assignment operators, also known as assignment operators, guys. After that, we have operators related to relationships. These examine the states and relationships of variables relative to each other. Fourth, there is the situation where more than one relationship occurs at the same time. You need to bring these together as well. These are logical operators. We have special operators used to increase and decrease values. These don't really have a specific name. I mean, there's no special name I can translate for them. That's why we call them increment and decrement operators. Guys, these are our operators. We will examine all of these one by one, and they're all very simple. One of them might make you think a bit. Other than that, the rest are things you already know, the basic things you've seen before, things you know from math. Now, let's go through these one by one in order. Yes, the basic mathematical operators. Guys, you all already know these. Addition. For addition, you use the plus sign, right? For subtraction, it's the minus sign. For multiplication, we use the asterisk here. Guys, for division, it's like this. We use the division sign, and for modulus, we use the percent sign. What was modulus, guys? Modulus is, or rather, the remainder of a number when divided by another number. We'll show this with an example anyway. In a moment, if you still can't remember it there, You'll remember it better. Now, in order for these basic operators to work, the first thing we need to know is actually an assignment. We have an operator for that. Guys, in other words, we have an assignment operator. We absolutely need to know this so that the operations we perform, it allows us to assign or define the results to variables. Let's make sure of that. The main thing here, the most basic assignment operator. Guys, it's the equals sign. We call this equals sign the assignment. Operator. What does our assignment operator assign? The value on the right side of the equals sign, of course, from your perspective, when you look at the screen, the value on the right side of the equals sign is transferred or assigned to the variable. So the point is, here you have a variable equals, and here you have a value. In other words, it transfers the value to the variable. We did this before, but let's repeat it. For example, I'm defining a numeric value. Alright, it's a number, like this. This was variable declaration, the type of the variable, the name of the variable. Here, number equals. When you write 1 here, you assign the value 1 to the number variable. You're loading it into that variable. This equals sign is the assignment operator, friends. Okay, so why is it necessary? It's necessary for this reason. We have a number, 2 numbers, integer s1, s2, and I'm assigning values to them. s1 equals, s2 equals. I defined 2 numbers like this. Now get out of here. Let's start with the collection. We will do the collection process. What are we doing? Let's call it integer sum. The total is equal s1 plus s2, the sum of 2 numbers. Friends, let's call it s2. Let's write it like this right now. 2 numbers. Total. I call this a plus. Sum. Here, what we put inside these double quotes is a text. Friends, this is a text called a string. You can enter values into it like this. Now, what was the plus variable when you said plus? It was performing the addition operation. Let's write it here right away for numerical operations. Attention. Addition in numerical operations. It is simply used to add 2 numbers, for example, 5 and 3. One is a string. The other is a variable that is a number. Adding them together. So, this is what I'm talking about. You can't add a string and a number together. I mean, the concept of addition is, you add 5 and 10, you get 15. But when you add a string and a number, it concatenates them as text. So, you'll see when I run the screen like this. Now, look. Here, when we add s1 and s2, it assigned the sum of these 2 numbers to this. Here, as you can see, mutton and the toplam variable, this is a numeric value. When you add this string variable and the numeric value, it just concatenated the 2. Guys, alright, pay attention to these things. If these aren't defined carefully, If you overlook them, unexpected results can happen to you. This is very. Let me show you right away with a simple example. Think of it like this. Guys, let's say S out. Okay. Let's say the sum of S1 and S2, alright? I'm putting a plus here. I wrote S1 plus S2. What do you think will be the result of this operation I wrote? So, when I run this, what do you think should come out here? Let's check the result together right away. What comes out? What did we get? The sum of S1 and S2 came out as 45398. Teacher, how is that possible? I mean, just 5 lines above, it was 551. How does something like this happen? Here's the thing, friends. Look, when you add a string and a number, it causes them to concatenate. So, the string and the number 453 got joined together. Now, when these two combined, they both became a string. When you add again, this time the number 98 also got joined to this string. So, what if I wanted to calculate these separately? In that case, we make use of the power of mathematics again. We use parentheses. With parentheses, the priority is always what's inside the parentheses. As you know, here, the string and the numbers are handled separately. So, this part is summed first, then it's combined with the string. As you can see, you can tell what the total is. Let's write these correctly too. Do not let them stand next to each other. Yes, in this way, we have also completed the collection process. Beautiful. Later, after that, friends and others. Division, multiplication, difference. So let's put it this way. Subtraction, integer, difference are equal. S1-2, S2, integer. Let's continue like this again. Let's call this multiplication. I say let's multiply by integer. S1 times S2. Finally, let's call it division. Divide. Integer. Section. I mean section equals S1 divided by Q2. I'm doing it. And print their output to the screen. Friends, subtraction. Let's call it the plus difference. Let's do these like this. As basic multiplication and division operations. Difference, product, and this one is quotient. Oops, go back. Yes, let's look at our results when we run it. I'm checking. The subtraction operation is 355. The multiplication operation is something in the 44,000s. The division operation came out as 4. Friends, the division operation came out as 4. Interesting. Calculation mechanism isn't working. Now, what were our numbers? 453 and 98. Let's do it like this. 453 divided by 98. What did it come out to? It came out as 4.62. But teacher, here it comes out as 4. Friends, it's normal for this operation to result in an integer. Do you know why it's normal? Here's the reason. When you divide these two numbers by each other, even if the result of dividing this number by that number is a decimal, the value assigned here is an integer. That's why, when you assign this to that, it will come out of an integer. That's the first reason. Secondly, if this wasn't an integer, but instead, if it were a double, what would the result be? The result would still be 4.0. But sir, where's the decimal part? Why doesn't it show up? Look, friends, when integers are divided by integers, the result is still an integer. Why? Because, remember when I was explaining variables to you, I mentioned the decimal part and the integer part, right? That's why when assigning, these need a place assigned. I said they can't be assigned because there's nowhere for them to go. Same here, friends. If you divide integers by each other, where is the decimal part supposed to go? They don't have that, friends. I mean, look. It doesn't matter at all if the variable here is a decimal. This is where the operation happens. Since the operation is on this side, if none of the numbers on this side have a decimal part, the result can't be a decimal. Because both are integers, and only integer boxes are used, the result will always be an integer. So, teacher, how do we solve this? To solve it, use casting. Just write double here. As you can see, the result comes out as a double. You can see it here, how it works, that it's the same. Did I explain it well? So, where the operation takes place is important. Don't assign it like this. This operation is completed. The result is assigned here, friends. The assignment operator does this operation in the CPU using integers. After an integer result comes out, then the assignment is made. That's why, when you're doing operations here, you should act accordingly. You can't do calculations with integers and then ask why the result isn't a decimal. Alright, you need to pay attention to this. So, teacher, what about these? If we had used double instead of integer here, it would have worked. I mean, if you had just declared these as double, there wouldn't have been any problem, friends. You could have worked directly, but when you make this double, you also need to adjust the total ints here, so you need to convert them to double. Or you need to convert the result here to an integer and assign it. Because the size of double and the size of integer don't match each other. That's why you would have to cast it. Is this part already done? It's double. So the result produced will be a double. Since you're assigning it to this, there won't be a problem, guys. Alright, good. Now, in our last topic, friends, what was it? Taking the modulus. Taking the modulus. What was taking the modulus, friends? What is the purpose of modulus? How do you perform a modulus operation? Well, for example, what should we say? What day is it today? The day I'm recording this is Monday. Monday. So, for example, what day will it be 23 days from now? How do you figure that out? There's a certain period here. Today is Monday, right? 7 days later, it's Monday again. So if I take 23 mod 7, meaning if I divide 23 by 7, the remainder. That's the day I'll land on. Look now, here. I'm right here at this moment. 7 days later, I arrive. I end up on Monday. 7 days later, I'm back. Again, I end up on Monday. That's the second 7. That makes 14 days. I go another 7. What happens? I'm on Monday. That makes 21 days. How many days do I need? 23 days. I'm at 21. I'm on the 21st day. 22, 23. What day is it? Monday, Tuesday, Wednesday. Instead of counting them, it's easy to count 23 days. But for 2,300 days, you can't count that way, by making it round. So, how do you do it? You divide the relevant number, in this case 23, by 7. You do 23 divided by 7. Does it divide evenly? It doesn't. There's also a remainder. How much is it? It's 2. If you divide 23 by 7, the remainder is 2. If today is Monday, 2 days later. Tuesday, Wednesday. Look, I found it. Taking the mod gives you the remainder here. Alright, that's what you call mod. So, let's do it. Let's say integer day equals how many days? 23 days. Alright, now, what are we going to take of this? We're going to take the mod, integer remainder. Let's say day equals not 23. Let's not say 23. That would be silly. I'm saying day mod 7, guys, and system out. Let's say remainder day plus remainder day. When I run it, you'll see here that the remainder day is 2. So this is actually what we mean by mod. With this, we've finished our operators. We'll continue with the other operators. Guys,